Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about grid tie inverter. So let's dive right into it. Now, first thing you have to understand, we are talking about power here, basically electrical energy that you consume in your household. At this point in time, it's slowly becoming rather than optional thing to have solar or wind to you should have this. And in upcoming years, as in as early as 2 to 5 years, the electricity prices are going up by such a exponential rate that you have to do this. So anybody who's investing in it right now, that are surprisingly doing it quite well. And one thing you have to understand, these things are not cheap. We are talking about low budget car kind of prices, and recently their price drop has become significant, combining everything. I mean, when I started, 1 kilowatt was around 1 lakh. Right now you can get a 5 kilowatt system in some places of India, basically some states with good subsidy and good installer. You can get around let's just say around 10 kilowatt of solar installation for a 5 lakh rupees. That is a very low budget car. So fundamentally speaking, it is a expensive investment. However, one thing you have to look out for is what we call return on investment. Basically, you spend boatload of money, how much money you're gonna make back. Now that is 5 to 8 years. What does that mean? That simply means after 5 or 8 years, 5 years is if you are using very low grade equipments, and 8 years if you are using very high grade equipments. You should be able to basically the amount of money you saved in your electrical bill will pile up to a point where it's no, you directly paid the amount of money that you invested on this system, and after that, basically every year after it it keeps working, is basically you saving you money directly. It just keeps saving you money. And a good system nowadays, because this system is now old enough, companies are old enough, mature enough, every technology has been ironed out, worked out, mass production, all that just combined. It's systems that are expensive. At this point in time, they can last you around 20 plus years easy, as in solar panels, 25 years easy. And after that, they only lose 80%, basically 20% of their power, 25 at best. So if you have a system where you can easily scale things up, even after 20 years, you can be just hey, just add more panels. You may not even need to do something expensive. You may just hey, I'll add 4 or 5 panels. That's it, done. So in terms of power, it's something that we have to do. We are slowly going from it was something that people want to show who they are green, they are doing it, to, oh no, you have to do this. And people living in metro cities, they have to do it. For example, in India, Bangalore, every Tom, Dick and Harry is trying to do it as quickly as possible, simply because otherwise the electrical bill is goddamn idiotically high. So what's the problem? Why not every Tom, Dick and Harry was doing it or doing it right now? Well, problem is batteries. The first thing you think about solar is you have solar, you have charge controller, you charge up your battery, and then you run inverter sort of that. Now, batteries, even lead acid batteries, are so expensive that it will make your solar installation look cheap. Let that sink in. That's how high battery prices are. I'm talking about lead acid battery and basic bitch lead acid battery, not industrial scale lead acid battery where you get each single cell. Now you may be why do you want each single cell? Well, so you can do what we call cell balancing, and you can also replace a cell in case of a damage happens, which does happen. If you have a lot of battery, you will have a scenario where one cell got damaged and destroyed everything else. So having a modular unit like this, you can change now. And these batteries do come with huge warranties, as in around 25 years warranty. So especially if you want a system that you bought it today and you don't have to think about unless something goes wrong for next 20-25 years, this sort of system you have to use. And do not even try to look up the price of these sort of things. They are idiotically high. They are generally used for electrical substation as a power backup. So that should give you some idea how expensive these things are. Now, running a whole household in India, every Tom, Dick and Harry has experience with what we call inverters. We have a 12 volt system, 24 volt system, 48 volt. That's common sight for us. However, whenever you are talking about this sort of inverter, we are generally thinking about during power cut, it should keep our lights on, it should allow us to use some essential equipment. Some places that would be fans, some places it would be basically television, some places it would be a computer. For me, I have to invest a lot in my inverter so I can run my computers without any interruption. So that does require certain amount of kilowatt, but generally most average household will be below 2 or 3 kilowatts. But the moment you want to be hey, I want to run my whole household, as in multiple air condition, a deep bore well pump, and 1 or 2 refrigerators, electric cars, even if you want to add that, then the kilowatt rating goes YOLO up. So that becomes a fundamental problem. And if you have to run the whole system, basically the whole household, you need to size your battery bank such a way that it should provide you power for 20 hours. That part people don't think about. It's like, yes, solar does produce power. Theoretically, if you ever live in a perfect place, you should get sun power for 12 hours, but you never get that. 6 hours is realistic. 4 hour of peak power is achievable. Now 4 hour, that simply gives you 20 hours of remaining power. So you have to understand, battery bank sizes becomes huge. Basically, how many kilowatt hour of your battery bank has to be, that's would be very high. You can have a household where, like, 6 kilowatt inverter is like good enough, but 6 kilowatt hour would be less than nothing for you. So you have to have, like, 12, 30 or 60 kilowatt hour. So in that time, budget will start to fly. And on top of that, how do you size the battery bank? You have to size it in such a way till the next sunrise, meaning throughout the night, basically when the peak power starts to go down, either your loads starts to go down. Especially, generally, many people who are running factories, they do that because it's like, the warehouse, let's say the warehouse only is working during daytime, they can survive on very small battery banks, simply because they only need to, in the early morning and late evening, they need energy for that time. They are not doing much at night time, so their power draw is low enough where kilowatt hour capacity can be low. But most places, household specifically, it's almost invert, because generally during daytime you will be working somewhere else. Again, I'm assuming the world will go back to normal sometime by 2022. So this is the problem. So grid tie was invented to create this, basically solve this issue. The idea is that the grid, basically the electrical infrastructure that you see around you, basically the power company that is providing you power, they're gonna act as a battery of you, because that electrical grid, if things going well, should work 24 into 7 into 365 into, basically they should work unless something bad happens. So in those sort of scenarios, they can act as a reliable system. What does that mean? That simply allows you to store energy there. Now you are not technically storing energy. All you are doing is basically selling electricity during daytime. When you are not in home, your solar farm, let's say it's a 10 kilowatt solar farm, it's producing power. Your basic equipment, let's say your refrigerator and your, let's say, one air conditioner is running, you're not consuming that much power. So what happens to that excess power? That is sold back. So basically that reverses your meter, electric meter. So you're like, okay, I'm exporting this much energy. Now let's say you exported 10 units of electricity. During night, you need to consume 10 kilowatts, 10 units of electrical energy. Then you're like, okay, tada, I got the energy back. So that's how you are using grid as a battery backup. Now your bill, if done correctly with a proper installation and your states allow it, you can sell the electricity and buy back electricity during night time. If done correctly, the monthly bill would be zero. Now again, nobody will ever get actual zero in electricity bill, because there is a maintenance cost into that. Especially in India, like if you have a single phase power, that electrical bill would be very less. But if you have three phase like I do, the bare minimum I'll get 1500 rupees per month. I can't do anything about it. That's like fixed cost. I'm gonna get that no matter what. So in those sort of scenario, you do have to be mindful about it. Do not think you're gonna get an electric bill that is zero. That's not gonna happen. So, and utilizing grid type does allow government subsidies. Most places will not even give you a single dime if you are doing what we call off-grid systems. If you are like completely battery, completely generator, completely solar farms and all that jazz, they don't care. Now when you are doing selling electricity to the grid, that fundamentally translates to that amount of load. Basically you are selling, let's say, 8 kilowatt of electrical energy. That 8 kilowatt is been reduced from any power plant demand. Now that single household, that translates to almost zero. But imagine 50-60 household. Now that's a bit of a energy production. 20-30 households, hundreds of households, multiple state districts, hundreds of them, grand total. Then you are talking about such a huge basically implementation where you are few megawatt of your energy is saved. So what does that mean? That means if you're burning coal, you have to burn less coal. That saves government boatload of money. And generally during daytime, there is what we call peak demand. So basically electrical cost is very high, and that time if you don't have to buy, like I'm talking about from government's point of view, don't have to buy electricity from power sellers, you're like GG. That's why it's in their best interest, basically in government's best interest, to install as many services as possible. Now it does come with one serious side effect. You may be like daytime, and if you live in India, grids are really not reliable in most places. Some new places, and especially the places that have like good government hold on things, you can get very good electricity, but most places not so much. I'm like expecting power cut daily, and like few hours power cut almost daily. So that's a thing that just happens. That's something that you have to deal with. In those sort of scenarios, you have to understand your solar system will flat out not work. I'm like, what the hell? I have daytime, I have sunlight, I have huge ass solar farm, I have big ass inverter, then why the heck I'm not getting electricity? Reality is this system is required by law, meaning if you have an inverter that has the capability of feeding power back into the grid, it must cut it out if it detects grid is down, because if grid is down, generally somebody would be working on it, or will be working on it very shortly. So if grid is down, somebody is working there, it's always assumed like that. So the alignment can be protected, because if you think about a 220 volt, what's gonna do first? 220 volt is lethal enough, and on top of that, electricity has this habit of jumping transformers. So basically you send 220 volt in, 11 kV will come out on the high voltage side, and if there is a worker working on that, bye bye the worker. So fundamentally this is a protection system required by law. So is there a way to run a grid tie inverter in in island mode, so to say? Yes, you need a disconnect and a way to trick the inverter thinking that is being connected to the grid. It's not very easy, and that's why it's not done that often, and not to mention many inverter companies will flat out avoid your warranty if you try to do something like that. So it can be done, but if the company says it can be done, do not try to circumvent it. You may have a scenario where things do not work out. So that's the grid tie aspect of it, and that issue assumes that you have a good system. Otherwise you have to buy huge as battery banks. Then we come to the first thing that most of the people who buy inverters, or like buy a solar system, generally interact with is what we call string inverters. Now string inverters generally take DC and they phase match it to the grid. Now that's the most expensive aspect of grid tie inverter. Inverter is not that expensive if it's square wave. The inverter starts to go up in cost the moment you start to achieve sine wave. Now grid tie is even more expensive. Now question is why? Well, the reality is it's doing what we call phase matching. Basically if you see three phases of electrical grid, it's like 120 degree apart, one is like 120 degree apart. So that means if you see the plot in an oscilloscope, you will see waves coming and going. Now that waves, each of the three phases, they will always have exact same gap, and they will be flow in the same rate. Now your inverter must match that, otherwise it will create a short circuit. So fundamentally it must match it, meaning basically peak point to peak point, dip point to dip point, heights and troughs all have to be matched. So fundamentally that's the part that makes grid tie inverters so expensive. And generally what grid tie does is like they will raise their voltage a bit up. So let's say I'm receiving 220 volts, so my grid tie inverter will be like 220 volts, I'm gonna sell it 222 volts, it will be 2 volts higher. So that will allow us to pump energy into the system. Now it must have what we call unity power factor. What does that translate to? That simply translates to it must have a scenario where the voltage and current must be in sync. Basically there cannot be how you have power factors, it cannot have leading or lagging, it must be one on one. So it requires unity power factor. And because of the reality of situation, you never have a scenario where anything is 100% perfect. So even if you are looking at the phases, so there is a maximum allowable tolerance, basically how much you must be within 1 degree of the separation. So if you run it through an oscilloscope, you should be good enough. It should not be like hey dude, it's starting to drift, your transformer is gonna go boom if that happens. So fundamentally 1 degree is allowable. If you're talking about a loose regulation, you can get away with 2, but the moment you start to reach 3 or 4 degrees, then yeah, your inverter will overheat, and after a while it's gonna catch on fire. So it must have phase angle matching to around 1 degree plus and minus. And it also needs a way to adjust what it call reactive power. I have provided a video down below. Reactive power needs to be adjusted because if you have a living in a scenario, let's say apartment complex or a lot of small houses where you have too many people using solar during peak time, you could run a scenario where everybody is feeding electricity, and you will reach a point where overall voltage could reach as high as 300 or 400 volts. So fundamentally you must have what we call reactive power for stability. Reactive power allows them to calm the voltage down. I have provided a video down below on how that is exactly done. Now we come to the new topic, the micro-inverter. Now inverter is a big thing, known thing, and all solar farms have that, but they are very big, clunky, expensive, and one point of failure, because generally most household will only have one inverter. They're not gonna have like 5-6 inverters, or like generally giant solar farm, like the biggest solar farm I have personally been with, it was like 500 kilowatts. Now in that scenario, the basically basically the customer wanted one big ass inverter. Are there inverters? Yeah, there are inverters that are like freaking 10 megawatts. So they wanted that, but the installer said advised against it. They're like, bro, try to have 100 kilowatt each. Now you're like, why? Well, in case of failure, let's say you had one inverter failure, you still have 400 kilowatts of energy left. So that's why they wanted to have that. Now micro inverter is that concept taken to extreme, where every single panel will have its own inverter. Now you're like, why the heck you want to do that? This is very inefficient. Yes, for giant solar farm, absolutely. For household which will barely have 10 panels, 20 panels, or 40 panels, that's doable. Now why would you want to do that? Well, a lot of technology helps in this sort of scenario, primary of being huge panel, meaning I started to look into solar around 2009 and all that jazz, and every Tom Dick and Harry was like, 100-watt panel, that's like big. That time it was like this big ass panel. Now it's like, who cares? It's like we have 300, 400 watt panel, and some are touching 500 goddamn watts. So in those sort of scenario, making this inverter starts to become feasible, because average household, let's say, needs 5 kilowatt. You don't need boatload of inverters. You're not necessarily like 50 inverters. You only need like 25. So it's far more feasible because of huge panels. And then it also creates a what we call system redundancy, where each panel is acting its own inverter system. So you have one panel failure, let's say damage through some debris, ice, or something like that. You had one panel damage, it's not going to take down your whole system. And that has the advantage, like each panel is, let's say, 400 watt, and you had like 10 kilowatt system. One inverter failure only translates to around 400 watt of energy lost. So fundamentally you will not even notice it unless many inverters started to fall. Now that's why generally most of these systems have very good app system, and they will start to notify you, bro, one of them is went down. And another aspect of the inverters is like the higher the voltage, DC side specifically, the more the cost. The biggest inverter I've seen, the ABB inverters, those that can go up to 1500 volt DC. Let that sink in. 1500 volt DC, that is so high, that is like you can literally do welding with that, like literally take out the solar lead and you can weld things with it. That's how powerful that puppy is. So that puts a lot of strain on electrical components, and electrical components that can manage that is idiotically expensive. Basically, if you're like, hey, give me a system that can handle let's say 12 volt DC, that like pitch plays, that's super cheap. Give me anything that can handle 100 volt DC. Now you start to go to average price. Anything that will handle more than 100, yeah, price goes exponentially higher. So generally trying to have lower voltage on DC side is desirable. Having lower amperage is also desirable, because ampere directly translates to how much copper you have to put on your PCB, how much stress your capacitors would be, how much your inductors have to put up the things. Basically on a component level, the component endurance is directly proportional to how much load it has to deal with. If it has to deal with lower voltage, lower amperage, lower everything, it will last much longer. Fundamentally it will last much longer. So that's why these sort of micro inverters are becoming so popular. On top of giving you that flexibility that any one panel can go down and you would not even notice a thing, these things last longer, because electrically speaking they are far more relaxed. They're like, chill bro, we got this, chill. And that translates to this puppy, like basically there's a N-phase micro inverter, IQ7 series and IQ8 series. At this point in time, they can have 25 years of warranty. And unless every Tom, Dick and Harry is lying, in Australia these are quite popular, and they have sold like few lakhs of this, and they have only found fault in 1 or 2. That's amazing, because like that's almost satellite level redundancy that is built into the system. And the only way they can achieve that is like if everything is low, the voltage low, amperage low, everything. The more the lower you go, the better, the more longer lasting it becomes. And it also gives us one cool advantage, that is easy installation. You just have a panel, that's it, done. You have just one AC cable. DC cables are expensive. DC high amperage cable are even more expensive. DC high voltage safety systems, good luck trying to figure out how much they cost, because they cost in what we call kidney and a leg kind of prices. They are very expensive. So this system simplifying all of that fundamentally means every Tom, Dick and Harry can just have this system. And this also allows you to have mismatch panels. Basically, if your one panel is 100 watt, you can do that. Generally nobody would recommend you that, because this will be more expensive than the panel, but you can do that. And you can have a scenario where it's like, hey, this is like 10 years old system and I need to consume more power. Tada, you can attach it. Now you're like, what about net metering? Generally net metering is done in what we call categories. They are never done in like, this is absolute. They're like, this is a 6 kilowatt system, does not mean you can only have 6 kilowatt. Generally they will give you a slot. Now it depends on your state to state. Sometimes states have like 1 kilowatt slot, 3 kilowatt slot and 10 kilowatt slot. So if you have 10 kilowatt slot, they only allows you to go to up to maximum 9 kilowatt. So if you had 8 kilowatt system, you can add another one panel without even thinking about it. So This is a really amazing technological development, and the fact that they have 25-year warranty, that's amazing. That means your panel and this system can outlast, and that will improve your return on investment. Yes, the initial cost will be a bit longer, but you don't have to worry about replacing the inverters, so that is something desirable. Only side effect is like having power backup in a grid outage scenario is very convoluted. Other than that, everything else about this system is awesome. I provided some Indian installers that have dealt with this kind of system. It's amazing. So this was my presentation on grid tie inverters. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.